Consider the parabola y equals x plus 2 squared. The original graph is shown on the set of axes below. For part A, we have the original graph is going to be reflected over the x-axis. For the first part of this question, we want to write down the corresponding mapping notation. For this transformation, we'll have x comma y, and that's going to map to, and if we reflect over the x-axis, our x values are unchanged, so we'll just have x comma, and the reflection over the x-axis is equivalent to multiplying the y values by -1. So we'll have y mapping to -y. For the next part of this question, we want to determine the equation of the image graph. So from our mapping notation, we generate two equations. The first one is that the transformed x values are just equal to x, and the transformed y values are equal to -y. The next step in this process is to solve for the non-dash terms. So for the first equation, we just have x is equal to x dash. For the next equation, we're going to multiply both sides of that equation by -1. This will give y is equal to -y dash. We use this information to substitute it into the original equation, which was y equals x plus 2 all squared. So wherever there's a y, I replace it with -y dash. And that is going to equal, wherever there's an x, I put x dash. So it'll be x dash plus 2 all squared. And then by convention, we always write this as y equals. So to get y by itself, I'll multiply both sides of this equation by -1. And we can say y1, which is the image graph, is equal to -x plus 2 all squared. And at this stage, we can leave off our dashes because we have our new equation y1. For part 3, the original graph is shown on the set of axes above. On that same set of axes, we want to sketch the new image graph. And we want to clearly show where the coordinates -3, 1, -2, 0, and 0, 4 have been mapped to. So as this is a reflection over the x-axis, we're going to multiply all the y values in these coordinates by -1. So if we start with -3, 1, that's going to map down here. And that point will still be -3, but it'll be -3, -1 as the coordinate. For the next one, we have -2, 0, and multiplying 0 by -1 still leaves it as -2, 0, so that point remains unchanged. The final point, 0, 4, if we reflect that over the x-axis, it will come down to here, and that point there will be 0, -4. So our parabola is going to look something like this when it's transformed. So that is a reflection over the x-axis for the graph y equals x plus 2 all squared. For part B, we're going to take the same original graph, but this time we're going to reflect it over the y-axis. For part 1 of this question, we want to write down the corresponding mapping notation. So we're going to have x comma y, and that is going to map to, and this time, if we're reflecting over the y-axis, it's the x values that are multiplied by -1. So that will give us -x, comma, and the y values remain unchanged. So the mapping is to -x, comma, y. For part 2, we want to determine the equation of this image graph. So we're going to have two equations generated from our mapping notation. The first equation says that x dash, the transformed x value, is equal to -x. And the second equation says that y dash is equal to y. The next stage of this process is to solve for the non-dash terms. So for the first equation, I'm going to multiply both sides by -1 to get x by itself. So this will give me x is equal to -x dash. The second equation already has y by itself, so that is y is equal to y dash. Once again, we use this information and we sub it into our original equation, which is y equals x plus 2 all squared. So wherever there's a y, we replace it with y dash. So wherever there's a y, we replace it with y dash, and that is equal to, and wherever there's an x, we replace that with -x dash. So we'll have -x dash plus 2 all squared on the right-hand side of the equation. And now our convention is to write it as y equals, and y is already by itself. So we can just say y2, the new graph, or the image graph, is equal to -x plus 2 all squared. So at this stage we can leave off the dashes because y2 is our image graph. For part 3, we have the original graph is sketched on the set of axes above, and on that same set of axes we want to sketch our image graph. And we want to once again clearly show where the coordinates -3, 1, -2, 0, and 0, 4 have been mapped to. So this time we're reflecting over the y-axis. So if we start with the coordinate -3, 1, we're going to multiply the x value -3 by -1, which will give us +3. So that point is going to map from here to here, and that coordinate is now going to be +3, 1. For our next coordinate we have -2, 0, and we multiply the x value by -1. So that means that it is reflected over the y-axis to this position, and that coordinate is now going to be 2, 0. The final point, 0, 4, we multiply 0 by -1 and it stays as 0. So that point is the same for the transformed graph. So drawing our parabola through those 3 points, we find that our transformed graph looks something like the parabola drawn in blue. So that there is the parabola y equals x plus 2 all squared when it is reflected over the y-axis. On this slide, we've got a computer to generate those graphs so they look a little bit neater, and we can see the reflection over the x-axis for the first graph and reflection over the y-axis for the second graph.